Wow! Excellent. There's a you, and there's a me, and together we are we. Allah. Like gasp. Wait. Is there no sound? Ooh, I have to see if I don't have a sound alert for that. Wait. All right, back pedal. Do streamers have sound alerts for watch streaks? Because now that I'm thinking about it, I watch a lot of streamers. I don't think I've seen anything trigger for that. I know I don't have anything set up for that. Have other people have stuff set up for that? Regardless, I'm gonna leave myself. Let me make myself a note here real quick. I actually want to see if that's a thing I can actually do. I would like to have a silly thing occur when that happens. I mean, granted, I want more, alerts, and I'm put together. Okay, but the level of how, I don't know. Let's see here. Sound alert, launch streak, question marks. Yes, excellent. That is a problem for future techie. All right, cool. Nope, that's gonna be, yep, that's there we go. That's more like it. All right, good. I'm curious about that, so I'm gonna look into that, but obviously not right now. And if I don't make a note, it'll be gone forever. Ask anybody, that's how that works. All right, let me see who's here. All right, brother, yeah, who's, oh, Porsche. Thank you, Porsche. Thank you for the watch streak. I started geeking out about it. I didn't even say thank you. Thank you. You have come to the madness that is this presentation. I mean, I don't know. I say words on the internet and then I show you things, and then after that we play games. So I mean, yep. It's fine. Let's see. We got Porsche and we got old. Oh, we got vibing up in here in chat. I like that a lot. Hello. Good to see you. I hope you're well. It is a me. It is a you too. And a hobbit. He's a toaster. Indeed. Hello. I am doing well. I have very much been living by the concept of live, laugh, toaster bath today. Okay, we vibe. That's what we doing. I desperately need to get that commission together because I have like many different ways I keep depicting how fun that would be, like the super happy face Protogen with like a bunch of bubbles around or something. I don't know. It sounds like it would be fun. It's a small slice of dark humor, and I feel like I'm here for it. The vibe, and indeed. Oh, that's a fun little emote. What do we got there? Ha! I love that. That's fancy. Okay. I got some hot tea of the, the liquid variety. And I got the makings of a plan. So here's what we're gonna do. I have been looking at so many high RPM fans over the last 2 weeks. I want to express something to you right now. There are a lot of options, and like it almost seems like even though there's a lot of options, that there's like technically 3 options, but there's a million. Okay, hold up a minute. So I purposely did not close all of my research tabs before stream because I did want to double check myself here. I'm going to tell you, I am currently using 18.5 gigs of RAM in just Firefox alone right now, because I have had all of the research tabs open, just shy of about 20 gigs worth, and they're still open. I probably should have closed them before I started stream, but I'm like, who needs to do that? Who needs housekeeping? Now, Porsche, it would only be greedy if it was DDR5. It is not DDR5. No, we don't do that here. I don't have that kind of money. not quite. But I can confirm we are using the RAM. Lots of it. Oh yeah. I'm almost positive it's DDR4. It's RAM is. I mean, yes, you are correct in your assessment. But so my research in my infinite amount of open tabs aside, I can confirm my phone is no better. I perpetually have so many tabs open, it doesn't show a number anymore. It just shows the infinite symbol. Now there isn't an infinite amount of tabs open, but I can confirm to you that I have enough that the phone just went, we're going to stop showing you a number because apparently you're not going to stop. And I'm like, I'm sorry. You gave me the opportunity and the ability to. Did you call my bluff? Did you not think I was going to do it? And then I did. Some old DDR2 in my parts bin. Wonder what it's worth now. That's an excellent question. 100 plus, by the way. Oh, I know for a fact it's over 100 in the Firefox mobile app because that's 100% where that's at. I can confirm, and that doesn't include any tabs that. Oh, actually, that is a separate count because there's also like the private mode you could dump into. So if it doesn't share cache, but that doesn't include the original count. So yes, an obscene amount of tabs. And that's what we do. So. All right, we're doing two things tonight. Okay, here's what's going to happen. I'm going to show you this very, very hefty little fan. It is a very small little fan. I've been sharing little snippets here and there on my server and a couple of the folks that I know that have been interested in this project. So you may or may not have seen this in a pre-recorded demo, but you're going to see it live. I've got a tiny fan, and I don't have one of those wind meters, but looking at the statistics of the math that was on the label for this particular fan, it spins at a maximum of 11 meters per second, or 24.5 miles per hour worth of wind. This thing is small, and my plan is to stick it somewhere in the nose of the Protogen Head. I haven't quite figured that out yet because I haven't printed anything yet. I haven't purchased any fabric yet. All of that comes after we figure out the electronics. But we figured out the main controller. We figured out the ability for the two of them to talk with each other. Now we've got control over the fan. I have to integrate that into the actual production code. I haven't done that. So tonight you're just going to witness the example code, but you'll see how, ironically, how simple this code is. And then I'm hoping, maybe not by next stream, but the stream after, I'm hoping I'll have some working example to show you the really big screens that will be in the actual head so that we could hopefully potentially start playing with those. I don't necessarily think I'm going to have enough together in the next 2 weeks to like start showing faces, but that's the direction we're heading in. Once we have that, I then want to take a look at integrating the microphone for animating the mouth, and then we'll talk about the battery that we're going to need to build for this, and then start 3D printing, cutting, and building. So this is, over the last couple of months, made really good progress. Step 1, overkill, PC build. Step 2, all the tabs. Step 3, profit, question mark? Yeah, exactly. That is 100% where we are. But I can confirm we have made some really, really, really good traction on me getting this off of the ground. And I've appreciated all of the resources that I've had shared to me from many individuals at this time. It has been a great help. So I'm going to show you that, and then we're going to play more Maniac Mansion. We're starting from the beginning because I blew us up in the last playthrough. But I have a little bit of a better gauge for how the game works. So I'm pretty confident we'll be able to get back to where we were without spending too much time to kind of hop back there. But again, I have a little bit more knowledge this time around on how the game behaves, being that it's a point-and-click adventure. So that's what we do. So without further ado, I'm gonna show you some stuff. First things first, we're gonna start with me switching scenes like a smart Protogen. I'm gonna click on that one. There we are. Okay, so this could arguably be condensed into even less, but I added some spaces functionality wise in the code here. It's more like 30 lines of actual functional code. But with the spaces and the print lines, it's like close to 70. So by just kind of stripping this out and putting it into the existing project, I don't think it's gonna be too crazy. So that should be fine. So first things first, we have on the bench behind me the small fan. My power supply set to 4.2 volts. and then the microcontroller is hooked up to the computer. The due to the nature of the way I have everything sitting, I think I'll pull up a pre-recorded video of just so I could show you what the actual setup looks like. But for now, I'm going to show you the live demo because I already know my noise canceling is going to filter out the sound of the fan. But the recording I took before with my phone, you could actually hear it because I wanted you to be able to hear it. And the more I thought about it, instead of trying to play with the microphone settings, I could just show you that. So here's the way it works. This specific code example is for a microcontroller with an ESP32 in it. I'm just going to jump to the meat and potatoes here. The one line that actually changes the speed is this one right here. And this LEDC write command does not work on the Arduino Uno. There are no additional libraries that are at the top of this project. So that is a piece of code that behaves directly from the base library for ESP32. There are different ways that you can interact to control one of these fans using an Arduino Uno, an Arduino Nano, which is a smaller microcontroller, different hardware that's built on a different instruction set. This code won't work on that. Up until this point, everything I've shown you would work across either microcontroller, because I would normally develop it on the Arduino Uno, move it to the ESP32, and then show it to you how I integrated it. I just so happen to have an extra Arduino Uno, so that's why I've been using that to kind of build out the code before putting it into production, quote unquote. But this particular example, being that it's easier, only works with this hardware. If it so happens to work with something beyond the ESP32 family, that's fine. But I can tell you for a fact, I copied this sketch. It does not work on the Uno. Ed Randalls. My point being is that what I'm showing you doesn't work on other hardware. That is the long and short of it. It's like trying to get into a standard transmission car and trying to drive away without shifting. It's not going to work. You're not even going to get out of the driveway before you blow up your transmission. The wiring is more or less pretty straightforward. I've got pin 3 connected to the control pin, so that allows us to actually change the speed of the fan to be quicker or slower. And then this is stuff that was way more complicated to do on an Uno, is to generate a frequency for the fan. In this case, most computer fans, including this one, runs at 25 kilohertz frequency. So that is how fast the waveform goes up and down over a preset length of time. I do not have a good way to visualize that example without an oscilloscope. I don't own one. And they're very, very expensive. So trust me in saying that we need this. And then we're going to continue, because I can't even think of a decent way to explain that other than signal goes up and down, and then the higher the frequency, the squishier together the blocks are on the screen. And then our fan speed is going to fit inside of a byte. So that's going to be a value between 0 for off and full speed at 255. The reason we're using this kind of odd set of numbers is because the LED write function expects a number somewhere between 0 and 255. So we'll do the same. And then we'll connect to the serial monitor that we see down here. We'll send a message saying that we're going to do the thing. We then configure our fan. Now the function is called LED-C attach, but we're using it to control a fan. That's totally fine. That's not going to break or bother anything. Just know that it's not an LED. And then we pass it the pin it's connected to. The frequency, which is how that waveform is going to look. And then they call it the resolution. It's just the full size of the I don't even know how would I even describe that. An 8-bit resolution. It essentially just tells the function your number is going to be between 0 and 255, because that's across an 8-bit number or a whole byte. That's very mathematical. It sucks, and I don't have a better way to explain it. But very simply put, you tell the function, here's the 3 things that make up my fan. And then to control the fan, we pass it the pin and then the speed we want to go. And the speed will be between 0 for off and 255 for full speed. We then tell it we're ready. You can ignore this comment about a potentiometer because we don't have one. That is code I forgot to erase before today. So we're going to pretend that's not there because we don't have one of those. And then this whole thing that I have here, this switching statement, we will not need for when we integrate it with the controller in the menu, because the menu is going to do these actions. I mean, granted, we're going to build something that probably looks kind of something similar, but the menu is going to control it. But just to show you a running example of what we're about to do, I built a really simple keyboard controllable menu here. And if we put in the monitor, this box down here, the letter D is in dog, the fan shuts off. If we do the letter C is in cat, we get a value of 85, which works out to 33% fan speed. And then 128 is perfectly half, and then 255 is full speed. Right now the fan is off, so the value that's behind my head is 0, and the fan is not moving. Once we choose a letter, which is what it's doing right now, it's waiting for us to do something on the keyboard, we then just simply tell it, set the new fan speed, and then we just pass it one of these 4 values. So we either give it 0, 85, 128, or 255. That gives us our very basic control. And then this speed percentage just takes I love this map function thing. Looked like ugly before, but now that I understand what it does, it's kind of amazing. A map function allows you to take 2 different sets of numbers and find the common ground between the 2 of them. So in the case of a percentage between 0 and 100%, we know that half of 255 is in fact 128, which means that if we map 128 inside between 0 to 100, that works out to being half. It just does some simple division for us. But when you're working with different sensor information, this makes that math really easy on one line. This just shows us how fast our spinning is a percentage. That's it. And then we delay, and that's it. So I don't think my microphone's going to pick this up. So I'm going to just cycle through the options so that you can hear what's happening. And then I'll load up that pre-recorded video so you can actually witness what's actually happening on the bench here. Because the way that I have this set up, I don't know, can I move those wires? I don't know if I'll be able to move them without accidentally shorting anything out. Yeah, let me run it through the keyboard here. Maybe I could do it. Maybe I could do it live. We could see here. The thing is that the microphone's going to cut out, which I don't like that. So we'll do a D in the keyboard here and click enter. And that's off. That's off. I meant to do C. So as you can see, nothing happened because that's off. And they'll do C as in Charlie. And the fan turns on. You can't really hear it, and I can barely hear it because it's kind of quiet. But there it is at 33% speed. It's spinning right now. And then we'll do a capital B as in boy. We're now at half speed. And I'm using just slightly more than half an amp worth of power at 4.2 volts DC. We'll then go to full speed. And now it kind of sounds like there's a vacuum cleaner in my space. And I'm using an amp worth of power at 4.2 volts. That is pushing a ton of air right now, 24.5 miles per hour. I don't know, can you guys hear the fan? I'm seeing zero activity on my microphone, so I'm going to vote no. So let me take a moment here. Let me get up the clip I want to show you that I pre-recorded, because that will make this super easy to do a little showcase action here. Let's see here. Through the power of looking through my previously sent messages, where am I at here? I'm going places. Yeah, I'm thinking about it. Come on, where the heck am I here? There's the server I'm looking for. And then I'm gonna do more. I want to let's see that, and I'm gonna close that. Thought about opening this beforehand, but didn't get around to it. Good times. Okay, and now, through the power of clicking way too many buttons, I'm gonna go back. Okay, we've got our power. All right, nope, I need to show that before we go back over. There we go. Okay, so this is actually going to show you what I do not have a good enough camera setup to show this live, but this will come better across. Supply set to 4.2 volts. It's currently pulling no amperage. We have the Matrix Portal S3 connected. That is the fan. One analog. The little blue guy right there. Compatible on this microcontroller, which is lovely. And I'm gonna move up here because I already talked about it. Activate. Okay, so that's at 33% power. A little bit of amperage. And then we'll go to B for half power. Spins a little faster. Pulls half of an amp. And then full power is a full amp. So we'll do A for full power. Spinny, spinny. And more power. Yeah, so that is essentially what we have set up right now. Now, obviously, when we go to stuff the fan inside of the head, there's not going to be a big digital power supply like that. But my point is just to tune it in to the voltage that we're going to need, and then from there, you know, tinker. But the way that my camera is currently positioned, that was the better of the options to show that. Yeah, cool, exactly. 24.5 miles per hour. Cool. Now, something that I did discover that is going to be incredibly helpful for this project is the fact that pins A1 through A4 are all digital, and they all support that PWM thing that we're doing actively right now to control this fan. So depending on how much space the code takes up to control these things, I may include more than one. For now, I'm going to stick it with one. And the reason being is that the project, this sample project that I have here, this is claiming it's using 17% storage and very little RAM to control this fan. I don't want to make a problem and leave myself no room to actually make the faces. And the other thing too is that I thought to myself, well, okay, well, what if I were to take more than one fan and hook it to the same control pin? Is that going to cause a problem? And the answer is yes, it does cause a problem, because the control pin on the fan, so there's 3 wires. There's the black one, the red one, and the yellow one. The yellow wire is the control wire. And what is happening in this example is that there is a pulse of electricity at 25,000 hertz or 25 kilohertz, up, down, up, down, up, down, right? And it's spaced to be at 25 kilohertz. At maximum power, it's putting out a full 5 volts of electricity to that pin. And if you add an extra wire for a different fan, so you have 2 of them connected, you're going to experience this thing called voltage drop. So the voltage is going to run down both control wires, and both fans at their full speed, quote unquote, will be half the maximum power they're capable of putting out, because they're going to share that 5 volts. There's going to be a voltage drop, and they won't run as efficiently as they could. But I don't want to introduce more bloat to the code, but I really wanted to be able to control that fan for 2 reasons. One, I wanted to make it, I'm already holding a controller in my hand to change my expressions. So I really didn't want to have to remove that controller from my hand to be able to go back to changing, to change anything else. Like, if it's built into the head, I want it to all be controlled from this menu. So I figured cooling should be integrated if I can do it. So there's proof of example. That's my plan for making this happen. And 2, having separate batteries and additional hardware, I wanted to try to reduce as much as possible by integrating it. For those of you who've seen suitors wandering around, walking around in their fursuits, you'll see that they take the fans, they wedge them inside of the suit head, whether that be in the mouth, or for Protogens in most cases, usually they'll snap off the visor, cool themselves off, and pop it back on. I wanted to make it so that it would be as seamless as possible, so that I wouldn't have to take the head off as often. Obviously, you're going to need brakes, right? This is not a thing to prevent brakes, but it is a reduction in what Uncle Kage, the chairman of Anthrocon, would refer to as breaking the magic. And that is the concept of you are the character. You are in the character. You are presenting as the character. And being able to, hold that, to bring it and keep it, so that, you don't quote unquote break the magic. I wanted to try to do that. So this was also the other reason why I wanted to do that. I have my work cut out for me, because I have to integrate this into the production code. And then I'm going to start doing some research on the additional screens. So we are going to continue to move this project forward. Out of curiosity, before we pivot gears, does anybody have any questions, concerns, silly things to say to me about anything I've shown you? Actually, while I'm waiting, if any of you have anything that you want to say at my face, I do want to briefly pull back up the other example, because the Uno code is just so much more difficult to understand. I did some additional research, and this code does work. I want you to know, but the way that this works was way uglier because you have to modify the timers of the way that the entire microcontroller runs at for this to work. And then you're doing something really bizarre with the frequency, and you're modifying an IRC. This just looks super ugly. Now again, I understand it's just a little bit of math here, that's fine, but whatever the hell's going on here and this, I started to try to, of course you don't have to be sorry, by all means, wander in and out as you need. This was way more complicated to set up, and then to try to transpose that over to what we're going to actually use. You could see that this is way more simple to control, because all you're doing is just telling the function, here's how fast the control waveform is going to be, or the frequency, and then how fast to spin the damn thing. Do you want fast? Do you want slow? That's it. That's all we're doing. So I was kind of caught a bit off guard with how much messier it is to try to do it over here in Arduino land on the Uno. But again, I literally just copied the switching statement because that's exactly the same between both of them. But yeah, no, it not so good. I am not shy to trying to understand some of these different shorthands, but trying to find an article to explain to me what on earth I'm looking at, I can admit was a little difficult to locate. Kind of got a little bit of an idea of these just being the system timers, more than just this comment right here. I was doing a little digging, and it's apparently because I'm using the ESP32, you're not modifying the timing of the processor that's on it. You're just generating an additional signal. That's it. And it's condensed. Welcome back from the ads. It's condensed into that one function. So it's surprisingly easier to use more robust hardware. ESP32 has more RAM, it has more storage than the Arduino does. Sure, it's a couple more dollars, and I literally mean a couple of more dollars, because I'm pretty sure the Uno's like a $7 board, and the ESP32's like maybe like 10 or 15 for a pack of like 2 or 3. Like the cost is a bit negotiable, but the nicer to use function that makes this not want you to bang your face off your desk is just built in, and boy, is that a lot nicer to play with. So yeah, more or less that's the code portion. So that pretty much wraps the first part of this evening up here. So give me a moment. I'm going to pivot us over to our game.